All right, so let's get started with section 8.5. We're going over the sum and difference formulas. So at the top of your page is just a little bit of review. So I'm going to actually just post the answers to the review portion. You can work through it on your own. I suggest that you just pause it, take about 5 minutes to go through each one of those problems just as a warm-up, and then just hit play and then jump into the rest of the video. So take a second, pause it, work it out on your own. I'll show you the answers in 5, 4, 3, 2, and here are the answers. Hopefully you worked it out correctly. If not, then just post any question that you have. But just make sure that you pay attention to the fact that the square root of 2 over 4 is not the same as 1/2. Just like when you have the square root of 3 over 6 over here on this side, that is also not going to reduce and just be 1/2. So here's a little bit more of the warm-up before we really get into the lesson, but I do want to go through these with you guys because this is more related to what we're going to be doing later on in 8.5. So the directions say rewrite the following values as a sum of special angle measures, show all steps, and simplify your answers. So when they say simplify your answers, they don't mean add it back together again, just to reduce the fractions that you have for your sums. So with 11 pi over 12, we can reduce that, or we can decompose it, which means to simply break it apart and change it to 8 pi over 12 plus 3 pi over 12. So now we have broken the 11 into 8 and 3, and now when we simplify it or reduce it, we can change the 8 pi over 12 to 2 pi over 3 because we divide both by 4, and over here we'll divide both by 3. So this will be plus pi over 4. So that is how you decompose the angle measures. Basically, you decide, okay, I can break whatever this number is into numbers that will form special angle measures. So another way to decompose 11, we could have just as easily changed it to 9 pi over 12 and 2 pi over 12. And those two would have reduced to 3 pi over 4 and pi over 6, which would have also been special angle measures. So there is no particular way that you have to do it, but as long as it reduces to special angle measures where your denominator is like 3, 4, or 6, or 2, then you know that you're on the right track. So let's do one more. Let's do number 2. So we can change the 7 and break that into 3 pi over 12 plus 4 pi over 12. And when we reduce it, that will be pi over 4 plus pi over 3. We divide the 3 and the 12 by 3. We get 1 over 4, and we divide the 4 and the 12 by 4, and that's how we get pi over 3. So now let's look at a couple in degrees. For 105 degrees, with the problems that are in degrees, you have to think a little bit more because it's not as obvious because it's not single digit numbers. But even with 105, normally if you see a 5 as in the ones place, usually you can break off 45 degrees and then just figure out what's left on the other side. So 105 could be 45 degrees, and then we're also left with 60 degrees on the other side, and then we're done changing it into a sum of angle measures. So with 255, again, if we break off 45 degrees, we'll also be able to break up the other piece into 210 degrees. And now for number 7, it's asking us to rewrite the values as a difference of special angle measures. So this time we'll change it to values that are subtracted. So pi over 12, again, could be a number of different values, but we'll keep it simple and we'll say that pi over 12 will be 4 pi over 12 minus 3 pi over 12, which is equal to 1 pi over 12. And then with 8, again, we see that 5 is in ones place, so usually that indicates that 45 degrees is involved in there somehow. So this would be 45 degrees minus 30 degrees for the equivalent of 15 degrees. And that is our warm-up again for decomposing angle measures. So now we are continuing on to the next page where we're actually looking at the sum and difference formulas for the cosine function. So up here at the top of your page, you see that we have the formulas that are listed. Basically, if you have the cosine of two angle measures that are added together, you can take the first angle, which we'll label as alpha, plus the second angle, which we'll label as beta, and we can plug them into the formula for alpha and beta as such. Likewise, if we have a difference of angle measures, like say it was 45 degrees minus 30 degrees, we can plug in 45 for alpha, we can plug in 30 degrees for beta into our formula and then evaluate it based on those angle measures. So now, looking at our practice, using the sum formula, it says find the exact value of the expression. So they give us cosine of 7 pi over 12. Before this point, we didn't really have a formula. 7 pi over 12 is not a special angle measure, so it's not easy to evaluate what cosine of 7 pi over 12 is. But now that we have our sum formula, we can decompose 7 pi over 12 and rewrite it as 3 pi over 12 plus 4 pi over 12, in which once we simplify, then we'll have special angle measures, and we can just plug those into the formula for the sum formula. It should be plus sign here and a plus sign here. Actually, those should be subtraction signs, so leave it the way it is on your paper. I kind of got caught looking at something else. So if we change, now we'll finish this problem that was already begun for us. We'll change 3 pi over 12 to alpha equaling pi over 4 if we simplify it, and then beta is 4 pi over 12, which is going to equal pi over 3. 4 pi over 12 equals 3, and then 3 pi over 12 equals pi over 4. So now we'll stretch our formula, we'll reduce those numbers, so we'll change it to cosine of pi over 4, cosine of pi over 3, minus sine of pi over 4 times sine of pi over 3. And now we just evaluate each one of these in our products. So cosine of pi over 4 is square root of 2 over 2. Cosine of pi over 3 is going to be 1/2. Sine of pi over 4 is square root of 2 over 2 again. And then sine of pi over 3 is going to be square root of 3 over 2. And then we simplify and we combine if we can. So this will be square root of 2 times 1, which is square root of 2, over 2 times 2, which is 4, minus square root of 2 times the square root of 3, which is the square root of 6, over 4. And now we can combine our numerators since the denominators are the same. So this equals the square root of 2 minus the square root of 6 all over 4. And we cannot reduce the problem any further, so we are done with this problem. So again, you want to decompose the unusual or not common angle measure into more common angle measures so that you can use in the formula to evaluate the expression. So let's move on to number 2. We have another sum formula situation. So we have 13 pi over 12. We want to decompose that into special angle measures. So if we have 13 pi over 12, we can change that to cosine of 3 pi over 12 plus, it should be a plus sign, cosine of 3 pi over 12 plus 10 pi over 12. And this should all be in our first set of parentheses. So we can say that alpha is going to be 3 pi over 12 and beta is going to be 10 pi over 12. And now we just plug it into the formula. So the sum formula, again, if you're looking at the top of your page, is going to be cosine alpha, cosine beta, minus sine alpha, sine beta. So we'll have cosine of 3 pi over 12, which we can reduce to pi over 4, times cosine of 10 pi over 12, which we can reduce to 5 pi over 6, dividing both by 2, minus sine of pi over 4, sine of 5 pi over 6. And now we'll have to recall what those angle measures produce in terms of our trig functions, but it shouldn't be too hard. We really went over a lot of this. Sorry for shaking the table. We went over a lot of this in our test 2 section, as well as section 8.1 and 8.2. So cosine of pi over 4 is square root of 2 over 2. Cosine of 5 pi over 6 is going to be in the second quadrant, so cosine is negative. It's 5 pi over 6, so cosine is going to be negative square root of 3 over 2, minus sine of pi over 4 is going to be square root of 2 over 2 again. And then sine of 5 pi over 6 is still positive in the second quadrant, so it's 1/2. Now we simplify by multiplying across. So square root of 2 times the negative square root of 3 is going to be a negative square root of 6 over 4 minus square root of 2 times 1, square root of 2 over 4. And now we have negative square root of 6 minus square root of 2 over 4. Negative square root of 6 minus square root of 2 over 4, and there is our second solution. Now we're going to use the difference formula. So this time, instead of using the sum formula, we're just going up to the difference formula, and it's still there at the top of your page. So cosine of pi over 12, you can change that into a sum. That's going to equal the same as cosine of 4 pi over 12 minus 3 pi over 12. So that will give you cosine of pi over 3 times cosine of pi over 4 plus, this time, the difference with the difference formula is that you have the opposite sign here. So cosine pi over 4 plus sine pi over 3, sine pi over 4. And then we evaluate all of these. So cosine of pi over 3 is 1/2 times cosine of pi over 4, square root of 2 over 2, plus sine of square root of 3 over 2. Oops, no longer any sign. It's just square root of 3 over 2 times square root of 2 over 2. And then we multiply across and combine. Since both of our denominators will be 4, we'll have the square root of 2 plus the square root of 6 over 4. And there is our solution for number 3. Moving on to number 4, I'll go through this one just a little bit quicker because we have a negative value. Also, this one is in terms of secant instead of being in terms of cosine. So we need to, of course, we're going to have to change it into cosine to apply our cosine formula. But also recall that secant is an even function. So when you have secant of a negative number, it's the same as secant of a positive number. So this equals the same as secant of 105. Now we need to apply our reciprocal identity. So we'll change this to 1 over cosine of 105 degrees. So now we can plug in our formula. We need to change the 105, so let's decompose it. That would be 1 over cosine of 45 plus 60. And now we just apply our formula. It's just that everything is in the denominator instead of it being in the numerator where it normally is. So everything will be underneath a 1 as a numerator. So we'll have cosine 45 cosine 60 minus sine 45 sine 60. Then we evaluate, so this equals 1 over cosine of 45 square root of 2 over 2. Cosine of 60 is 1/2 minus sine of 45 square root of 2 over 2 again, and sine of 60 square root of 3 over 2. And then all of this equals 1 over square root of 2 minus the square root of 6, and all of that is over 4 now. But since we have a complex fraction here, we can simplify. We'll multiply everything by 4 at the top and the bottom. So that will leave us with 4 over the square root of 2 minus the square root of 6. Now we're moving on to the sum and difference formulas for the sine function. And it works a lot like the formulas for the cosine function. It's just that there's a little bit of a difference in the formulas, of course. So instead of cosine and cosine being first and then sine and sine being second, notice that now it's a combination in each term. However, you have sine alpha, then cosine beta, and then it switches. And it's cosine alpha, then sine beta. And notice that in the sine sum and difference formulas, whatever the sign in the middle is consistent in the formulas. Whereas with the cosine formulas, they change for the sum and differences. So we need to decompose our angles and then apply the formulas and then evaluate the functions based on those formulas. So we can decompose 75. This will be 30 and 45. So alpha can be 30, beta can be 45, and we're plugging that into our formula up here. So sine of 30 plus 45, so alpha is 30, beta is 45. That's going to equal sine of 30 cosine of 45 plus plus cosine of 30 sine of 45. And I'm writing it to be consistent with the formula up here, but if you switch and put, if you like to keep sine first, you can do sine alpha cosine beta plus sine beta cosine alpha. So if it's easier for you to remember the formulas that way, you can go ahead and plug it in like that too. They all work out the same. So sine of 30 is 1/2 cosine of 45 square root of 2 over 2 plus cosine of 30 is going to be square root of 3 over 2. And then sine of 45 is square root of 2 over 2. So now we have square root of 2 plus square root of 6 over 4, and we're done there. All right, now I'm going to move on to numbers 2 and 3. We'll just skip through number 2, but you know for number 2 you can use alpha equals 3 pi over 12, which will equal pi over 4. And then for your other angle, you can use beta equals 8 pi over 12, which again equals 2 pi over 3. And then you can just plug it into your sum formula where alpha and beta are pi over 4 and 2 pi over 3, and then you'll work it out. So now for number 3, we're going to use a different formula. So we can change the pi over 12 to sine of 4 pi over 12 minus 3 pi over 12. And remember, for your difference formula for sine is when you keep the sign the same, but remember sine and cosine will alternate in each term. So this will equal sine 4 pi over 12 cosine 3 pi over 12 minus cosine 4 pi over 12 sine 3 pi over 12. And we can reduce it. So sine of 4 pi over 12, I could have skipped this step, but sine of 4 pi over 12 would be pi over 3 cosine pi over 4 minus cosine pi over 3 sine pi over 4. Sine of pi over 3 is square root of 3 over 2. Cosine of pi over 4, square root of 2 over 2, minus cosine of pi over 3 is 1/2. Sine of pi over 4, square root of 2 over 2. Multiplying these out, so that will give us square root of 6 minus the square root of 2 over 2. Moving on to these three down at the bottom, these are practice problems, especially for your benefit. It says verify the trig function of special angles, substitute known values to simplify the expression. So I will give you a 5-second countdown so you can pause the video, work the problems out, and then just come back and check them on your own. So if you want to, then take a 5-second pause. 5, 4, 3, 2, 1. And here are the problems worked all the way out so that you can see it. So pause it, take a look at it if you need to, and then we're moving on to your sum and difference formulas for your tangent function. So we'll do one with the difference, we'll do one with the sum, and then move on to the more interesting problems. So with tangent of 15, we can change that into a difference, where in this case, it'll be tangent of 40, 45 minus 30. So it's tangent of 45 minus 30, where alpha is 45 degrees, beta is 30 degrees, and then we'll plug that into our difference formula. So the formula is tangent alpha minus beta is up here, as you can see. So we will have tangent of alpha, which is 45, minus tangent of beta, which is 30, all over 1 plus tangent 45, tangent 30. And then we evaluate it. So tangent of 45 is 1. Tangent of 30 is going to be 1 over the square root of 3. 1, and then in the denominator we have 1 plus 1 times 1 over the square root of 3. And notice that we have a complex fraction here, so we'll multiply everything by the square root of 3 at the top and the bottom. So the numerator times square root of 3, and we'll distribute that in here, and then we'll do the denominator times square root of 3, and we'll also distribute that in here as well. So the square root of 3 times 1 is the square root of 3. Square root of 3 here, they cancel out, so it's minus 1 we're left with at the numerator. All over square root of 3 times 1 is the square root of 3. And then here the square roots of 3 cancel, so it's plus 1 here. And this is our solution. Moving on to number 2. Now we have one where we can use the sum formula. We can change 7 pi over 12 to tangent of 3 pi over 12 plus 4 pi over 12, or you can put 4 pi over 12 and 3 pi over 12. It doesn't really make a big difference. You should still get the same solution either way. So now we evaluate it. You know 3 pi over 12 is also going to be pi over 4. So tangent of pi over 4 again, plus pi over 3 for the 4 pi over 12. So we will have, we're using the sum formula, so tangent pi over 4 plus tangent 4 pi over 12 all over 1 minus tangent pi over 4 tangent, should be pi over 3. So this 4 pi over 12 is the same as pi over 3, and we'll just evaluate it that way in the next step. So this equals tangent pi over 4 is 1 plus tangent of pi over 3, again, is 1 over the square root of 3 over 1 minus tangent of pi over 4 is 1 times tangent of pi over 3, which is 1 over the square root of 3. So now, similarly to our last example, we'll multiply everything by square root of 3. This will leave us with the square root of 3 this time plus 1 over the square root of 3 minus 1. Oh, small correction. On this last example, I evaluated tangent of pi over 3 and I made it into 1 over the square root of 3. Tangent of pi over 3 is actually just square root of 3 by itself. So let me go back and cancel out these steps. So this should equal tangent pi over 4 is 1 plus tangent pi over 3 is the square root of 3. Here we go. And then 1 minus 1 times the square root of 3 would just be 1 minus the square root of 3. So here's the corrected version of that problem. All right, so now moving on to these problems, which is where it begins to get a little bit more interesting. So we're still going to be ultimately applying our sum and difference formulas in this section. Now we just need to do a little bit more work on the front end. So they give us information about an angle, and they also give us a function value. They tell us which quadrant the angle is in, so that we can use all of this information to ultimately draw a triangle and use the triangle that we draw to find the rest of the information that we're going to be plugging into our formulas later on down the line. So now, in this first problem, they tell us sine of, in this little Greek letter here is a gamma, it's a lowercase gamma. So sine of gamma is 5 over 13, where the angle measure gamma is between 0 and pi over 2. This tells us that our angle measure is in quadrant 1, so we can go ahead and draw a triangle in the first quadrant, which will have this orientation, and then everything is positive in the first quadrant. So our opposite side is 5, our hypotenuse is 13. We can go ahead and use the Pythagorean theorem and find out that our other leg is going to be 12. And now we label our angle that's given gamma for our reference angle in the triangle. So there's the angle, and now we evaluate the function with this information from our triangle. So sine of gamma plus delta, which is our other Greek letter here. So we know what gamma is, but we need to figure out what delta is. So now we got to go over here and figure out what our delta triangle looks like. So this time they tell us delta is between 0 and negative pi over 2, which means that delta is going to put us in the fourth quadrant. So we use the information to draw the triangle, and then we determine the rest of the triangle using the Pythagorean theorem. So if delta is between negative pi over 2 and 0, that means that this triangle is going to be going down into the fourth quadrant. So cosine is our adjacent side over hypotenuse. So we can label the triangle accordingly. So this would be 8 square root of 113. The hypotenuse is 113. Again, Pythagorean theorem will lead us to find that this side length is 7 square root of 113. And because it's in the fourth quadrant, the vertical distance is negative. So our sine value for delta will be negative. So here is our delta. So now, for sine of gamma plus delta, for our gamma angle measures, we'll use this triangle. For our delta angle measures, we'll use the triangle up over on the right. So sine of gamma plus delta, we can write out our formula. That will give us sine of gamma cosine of delta plus cosine of gamma sine of delta. And then we just evaluate, and we plug in our values for sine and cosine of gamma and delta based on our triangle. So sine of gamma is based on this triangle here. So sine of gamma is 5 over 13. Cosine of delta is based on our other triangle on this side, which is 8 square root of 113 over 113. And then plus, this time, cosine of gamma is based on the gamma triangle. So that would be 12 over 13. And then sine of delta is based on the delta triangle. That would be negative 7 square root of 113 over 113. Then we do the multiplication across like we did before. 5 times 8 is 40. Square root of 113. Let me write it in so you can see it. So 40 square root of 113 minus, because we're doing 12 times negative 7, that would be minus 84 square root of 113 all over, and we multiply 13 and 113 together. That will give us, and 13 times 113 will give us 1, 4, 6, 9. And since both of these have square roots of 13, and then we can combine across our numerator, since both radicals are the same, that will leave us with negative 44 square root of 113 over 1469. And once you go over to B, if you want to practice B, again, you can pause it, but just to give you a reminder, again, for your angle measure gamma, when you plug in tangent of gamma, you're going to this triangle on the left side, which is going to be 5 over 12. And then when you do tangent of delta, that will be the triangle over here on the right. Be careful with your negative sign. That will be negative 7 square root of 113 over 8, which means the square roots of 113 will cancel. So tangent of delta will just be negative 7 over 8 when you simplify it. I'll give you 5 seconds to pause it. 5, 4, 3, 2, 1. And now moving on to page 6. Skip over a page because that was just more practice problems for you guys in case we were doing it all together in class. You're more than welcome to work on those on your own just for extra practice. But now let's move on to our final page. So we have sine inverse of 5 over 13 minus cosine inverse of negative 7 over 25. So as you can see, we kind of have gone back to looking at inverses again. If you remember from sections 8.1 and sections 8.2, these inverses are back. So remember that first and foremost, whenever you evaluate an inverse function, that will always leave you with the angle measure. So this is some angle measure minus another angle measure. So we can label our angle measures actually as alpha and beta. And now you see we're simply doing a difference formula for a sine function. So we're doing sine alpha minus sine of alpha minus beta, where alpha is this angle measure and beta is this angle measure. Now, just like we did for the previous examples that we worked on, we are going to have to draw a triangle that corresponds with alpha and beta. So sine inverse of 5 over 13, so we have an inverse sine function and it's positive. And remember, sine inverse is positive in the first quadrant. So our alpha triangle is going to be in the first quadrant. So sine of alpha is going to be opposite over hypotenuse. We have another 5, 12, 13 triangle. So here's our alpha triangle, and then our beta triangle. Cosine inverse is negative in the second quadrant, so our beta triangle is going in this direction. And here's angle beta for our reference angle, and then cosine is negative 7 over 25. And here our hypotenuse, if we apply the Pythagorean theorem, is going to be 24. The vertical distance is positive because this triangle is in the second quadrant here. So now we can rewrite our formula just to recall it. Sine of alpha minus beta equals sine alpha cosine beta minus cosine alpha sine beta. And then we evaluate these based on our triangles. So sine of alpha is 5 over 13. So we have 5 over 13 for sine alpha. Cosine of beta is negative 7 over 25. Cosine of alpha is 12 over 13, so minus 12 over 13. And then sine of beta is going to be 24 over 25. So 24 over 25. And then we simplify these values. So 5 times negative 7 will be negative 35 over 13 times 25, which will be 325, minus 12 times 24 is 288, and it's also over 325. So our final answer, once we simplify, put it all together, is negative 323 over 325. And there you are. Let's look at one more example before we wrap it up. So now we have a cosine function where our angle measures are written as inverses. So again, we can label our angle measures as alpha and beta. So alpha is tangent inverse of 40 over 9. Tangent inverse is positive, so that is a triangle in the first quadrant. We have 40 for the opposite, 9 for the adjacent. Tangent is opposite over adjacent. That's how we get 40 and 9. Our hypotenuse, if we go ahead and evaluate it and use the Pythagorean theorem, we get 41 here. Here is our alpha, and then our cosine inverse this time is also positive. So our beta triangle is also going to be in the first quadrant. Here's beta, and that is adjacent over hypotenuse. This is a 3, 4, 5 triangle. So using the Pythagorean theorem, here are our two triangles with all sides labeled. So now we have a cosine difference formula. So we're doing cosine of alpha minus beta. So this will leave us with cosine alpha, cosine beta, plus sine alpha, sine beta. Nope, it's minus. Still minus. So now we evaluate. So cosine alpha is going to be 9 over 41. Cosine beta is going to be 3 over 5. Sine alpha, I'm getting a phone call. Minus sine of alpha, which will be 40 over 41. And then sine of beta, which is 3 over 5. So then we simplify it. We'll have 27 over 205. And our denominators will be the same, so we can put the numerators together. So 27 minus 120 over 205. And we'll subtract these, so that will be 93, negative 93 over 205. Right, 93, 27, 120. Yep, so that is our answer. If you want to work this last one out on your own, you can pause the video and I'll reveal the answer in 5 seconds. So go ahead and pause it. 5, 4, 3, 2, 1. And here's the work for the final example.